Unit 4, Objective 1, Simplifying Rational Expressions. Okay, so as we're simplifying rational expressions, typically you want to be thinking a lot about factoring and reducing. Now, that's not to say that that's what happens every single time, but almost every single time. There is a lot of factoring and reducing. Okay, so sample problems to simplify, identify excluded values. Now, excluded values are zeros in the denominator. Zeros in the denominator. Even before reducing. Because if we have a zero in the denominator, dividing by zero causes the expression to become undefined. Now, typically, you want the denominator to be in factored form, usually, if before you identify the zeros in the denominator. Now, for example, problem number 1 here, the denominator actually is in factored form already. 12 times a to the 5th times b to the 2nd. Now, you can start by identifying the excluded values, or you could do the excluded values at the end. Don't forget to do them. A cannot equal 0 and B cannot equal 0. So there are the excluded values. Now, the simplifying of it. Well, if you're in factored form, you reduce the fraction. So, for example, 40 and 12. Well, let's see. 4 goes into 40 10 times. 4 goes into 12 3 times. And we have a times a up top and 5 a's being multiplied on the bottom. So which one has more? Well, there's more a's on the bottom. So how many a's are left? Well, a squared left in the bottom. Now, we can only do this because we're in factored form already. Up at the top, b to the 7th, and the bottom, b squared. So there are more b's in the top. How many more b's? 5 more b's, so b to the 5th. Okay, so what are we left with? We're left with 10b to the 5th over 3a squared. And don't forget, a cannot equal 0 and b cannot equal 0. Okay, problem number 2. 5 plus 4x minus x squared all over x squared minus 25. Okay, so, well, again, think factoring and reducing. So factoring, of course, the denominator is difference of squares, so x minus 5 and x plus 5. Okay, now the top, the highest power of x is negative, so what you could factor out a GCF of -1 right now. We don't have to. We can factor it the way it is. The GCF is 1. It is a trinomial. So it looks like 5 and 1 and x and x. Okay, and I want a positive 4x in the middle, so it looks like I need a positive over here with the 1 plus x and a negative here with the 5 minus x. And so I'm now factored. Now, what reduces? Well, common factors reduce. Okay, common, same factors reduce. Do we have anything that is exactly the same? No. But notice that the x minus 5 and the 5 minus x are very, very similar. In fact, if I factored out a GCF of -1 out of one of them, so for example, remember we talked about factoring out that GCF of -1 out of the numerator. So if I factored out a GCF of -1 out of the 5 minus x, that would be -1 times, and it would become -5 plus x, in other words, x minus 5. So I've replaced this part of it with -1 times -5 plus x. And so now that is exactly the same as x minus 5. And so I can reduce that one with this one, leaving behind ones. Now, don't scribble things out. Make it so we can still see what's there. Okay, so final answer here, I've got 1 plus x over x plus 5. Don't forget about that GCF of -1. Now, ideally, final answer, you have as few negatives as possible. That's the nicest mathematical form. Now, -1 is -1 over +1. So -1 over +1 times this fraction out here. There's different ways we could do it. The nicest way to write it is just to do a negative kind of lined up with the fraction bar right there. So you're saying that it's -1 times that fraction. That is the nicest way to write it. Okay. You could have a negative distributed to the numerator. That would have more negatives, so it's not as nice. You could have parentheses around the numerator and negative on the outside, but then we're writing the parentheses. So really, this is the nicest way. If it was multiple choice, it'd be like that. Now, on the other hand, what about the 1 plus x? Could it be x plus 1 instead? Sure, addition is commutative. Excluded values. Maybe you can see it right here, the x squared minus 25, but just to be safe, if you're in factored form, x cannot equal 5, x cannot equal -5. So x cannot equal plus or minus 5. Problem number 3. Okay, so x to the 4th minus 16 all over x cubed minus 2x squared plus 4x minus 8. Okay, well, this one's a little bit more challenging. You know, the denominator, 4 terms, looks like grouping. So let's see, x squared for the first 2 terms, GCF, so x minus 2. Looks like a GCF of 4 for the last 2, x minus 2. Yep, that looks good. I've got x minus 2 common factor here. So we have x minus 2 common factor and x squared plus 4 is left behind. Okay, now that's factored. And the numerator here, that is difference of squares. I have x squared minus 4 and x squared plus 4. Okay, right now I do notice that the x squared plus 4 is reduced. That's nice. And, well, x squared minus 4, isn't that difference of squares again? So we've got x minus 2 times x plus 2 and over x minus 2. And so the x minus 2's reduce, and we are left with x plus 2. Okay, so x plus 2. Now, what are the restricted values? Okay, now we really are just looking for real numbers, but I mean, if we could go into the imaginaries if you want. X cannot equal 2. And now if we're restricting ourselves to just the real numbers, then that's all that we would have, because x squared plus 4 cannot equal 0 in the reals. On the other hand, if you wanted to open up to the imaginaries, we could go ahead and get a couple of values that would cause it to become 0. But we are restricting ourselves to the real values that need to be excluded. Problem number 4. Okay, now at this point, we might start having some direction saying perform the operation and then simplify. There is some of that that's on the worksheet. So let's say we have x squared plus 6x plus 9 over x cubed plus 27, and that's all over another fraction, x squared plus 7x plus 12, I said, over x cubed minus 3x squared plus 9x. Okay, now if you have a fraction divided by, that's really what this is. It's a fraction divided by another fraction. Well, what do we do when we're dividing by a fraction? Don't we flip and multiply? Yes. So this is really the top fraction, x squared plus 6x plus 9 over x cubed plus 27 times, and we're going to flip the bottom one and multiply. So x cubed minus 3x squared plus 9x over x squared plus 7x plus 12. So if the original problem on the worksheet is this fraction over a fraction, you don't necessarily have to write down the original problem. You could go ahead and write it as the top fraction times, and you flip and multiply that bottom fraction. Okay, well, the factoring and reduces still applies here. Okay, and so, you know, where do you start? Maybe you start with the easiest one. Maybe you start with the hardest one. I'd say start with the easiest one, whichever one looks easiest to you. Maybe you got the x squared plus 6x plus 9. Maybe that one's really easy for you. So that's x plus 3 times x plus 3, or x plus 3 quantity squared. Maybe you think that the x squared plus 7x plus 12 is the next easiest, so maybe you're doing that one next, x plus 3 times x plus 4. Maybe it's the sum of cubes you thought was easiest. Well, x plus 3 times x squared minus 3x plus 9. Or maybe you thought the GCF. You know, I mean, it doesn't really matter which order you're factoring in, but you do need to factor things. There's a GCF of x, so x times x squared minus 3x plus 9. And so now that it's all in factored form, now if you multiply fractions, don't you just multiply straight across? Yes. So effectively, everything in the numerators, if we were to perform the operation, all the things in the numerator are in the one numerator, and all the things in the denominator are in the one denominator. So that means any common factor in the numerator can reduce with any common factor in the denominator. Okay, so for example, an x plus 3 can reduce with an x plus 3. Now, does it have to be that x plus 3? No, you could have chosen the other x plus 3. X squared minus 3x plus 9 can reduce with the x squared minus 3x plus 9. And we also have another x plus 3 and another x plus 3. Okay, and so we're left with x over x plus 4. Okay, now that is simplified. Now, once we get to the perform the operations, which is, we're not going to make you check for the excluded values also. So you can just perform the operation and simplify as much as possible. By the way, that is all it simplifies. It does not simplify anymore. Problem number 5. Another perform the operation. Okay, so x squared minus 4 over x squared minus 4x plus 4 times x plus 3 over x plus 2 divided by 2x plus 6 over x minus 1. Okay, now, order of operations, what do we do first, multiplication or division? Well, multiplication and division are equal operations, and so therefore, you do the one that you get to first as you go from left to right. So we actually do times before the divide. But if this is the original problem, I mean, again, we're dividing by fraction. How do I divide by fraction? You flip and multiply. So flip the second fraction, and we're going to change it to multiplication. So if this is the original problem, perhaps you're writing out, maybe even you're writing it out in factored form. X squared minus 4. Oh, well, that's x minus 2 times x plus 2. And x squared minus 4x plus 4, that's x minus 2 times x minus 2, times x plus 3 over x plus 2. Maybe you put parentheses around them. Times, because we're changing the division to multiplication, and I'm going to flip and multiply. So x minus 1 is on top, and 2x plus 6, but there's a GCF of 2. So 2 times x plus 3 is in the bottom. So again, much like the previous problem, common factors reduce. So x minus 2, x minus 2. Okay, x plus 3, x plus 3. And, oh, there is one more, x plus 2 and x plus 2, leaving us with x minus 1 over x minus 2. And that's as much as that one simplifies. Wait, I just noticed the GCF of 2 right there. It's good to pay attention to that. So we need that. Okay, so 2 quantity, sorry, here it is, x minus 1 over 2 times the quantity x minus 2 in the denominator. Could you distribute the 2 in the denominator? Yes. X minus 1 over 2x minus 4. That would be fine. Do you need to? No, you do not need to. This is simplified. Okay, so we are doing worksheet 1. Several problems there for you to practice. Now, when we are reducing opposites, like this right here on the second problem, I don't necessarily need to see you factor out the GCF of -1 and reduce. You could simply reduce them and put a -1 in place of one of them. What do I mean by that? So for example, if you have A minus B over B minus A, and they are opposites. In other words, you know for certain that if you factor a GCF of -1 out of one of them, they would then be exactly the same if you factor out that GCF of -1. So be careful, make sure that they are definitely opposites. It's typically in this form, A minus B and B minus A. So if you're in that form, don't necessarily need to see you factoring out the GCF of -1. You could simply reduce the opposites, put a 1 in place of one of them, and put a -1 in place of the other one, and overall, then that one is -1. And so don't necessarily need to see the GCF of -1 being factored out before you reduce. Okay, so keep that in mind too.